Okay, let's take a quick look at our Module 1 review, which is going to be broken into two parts. The first part is the looks like a worksheet that we printed out for you. There's a few questions that we felt like really should have been added to the review that were not reflected in the textbook. So we wanted you to have as much preparation as possible. And so what we did here is we made up a few questions that seemed to reflect a little bit more of the knowledge that we were hoping that you would have. So the first topic that we wanted you guys to know was our segment addition postulate. And that segment addition postulate that we've said quite a few times is that the left side plus the right side equals the whole thing. So if we were to take these two pieces and add them together, we would have 17x. And if you take negative 7.9 and negative 6.5, you're going to get negative 14.46. Now, this bothers some people because the addition of negatives, but remember, if you owed $7 or almost $8, and then you borrowed more money, your debt is going to get worse. So remember, you're actually adding those two numbers together in a negative way. So 7.95 plus 6.5y is 14.46, but then that's a negative. And of course, that answer is equal to 33.14. We're going to go ahead and add that 1446 to both sides. And we're down to 17x equals, let's see, I think that was 47.6. And then when we divide both sides by 17, we got a nice easy answer of 2.8. So notice that in a geometry class, it is very typical that when you end up with saying that our answer is 2.8, we're sometimes not done, because in this case, I want to know what is the value of AB. So I need to take 6 times 2.8 because it's 6 of those x's minus 7.95. And I found out that AB is 8.85. Secondly, let's take 11 times that x and then subtract 6.51, and that value is 24.29. Now, again, if you wanted to check your answer on a test and make sure you were correct, I would suggest that you add those two numbers together and make sure you do get it at 33. Okay, so our next question says we have H right here, and it lies on AB. But it has one more little piece of data, and it says it's the midpoint. So I know that this side over here and this side over here are the same length. Even if my picture doesn't seem to reflect that they look the same, it is. It says that AH is 3x plus 7, and HB is 22.5. Now again, as I mentioned, AH and HB have to be the same. So in this case, really hoping that buzzer goes off soon. Okay. So rather than doing left side plus right side equals the whole thing on this one, because it's specifically a midpoint, I could just say the left side and the right side are identical. So let's go ahead and subtract 7 from both sides. And then if I divide by 3 on both sides, I got a nice easy answer of 7.5. And in this particular case, we were actually done with that problem. That's all I asked for. Now, the angle addition postulate is very, very similar. And I notice a lot of you guys in class are just not getting into that hang of actually using the diagrams that you're provided very well. Make sure that you take the time to put the stuff in there. So angle ABD, which is this angle right here, is 84 minus 2x. The angle right here, it says that DBC, this angle is x plus 15. And it says that the whole thing right here is 94. So again, what I could say is the top angle plus the bottom angle equals the whole thing. That's the angle addition postulate, that the two parts make the whole. So if I were to add these together, I should get 94. Now I do have to do a little bit of combining like terms, and I have 84 and 15 makes 99. Those are definitely like terms. I have a negative 2x, but a positive x. So if I lost 2x, but I gained one of them back, I still am down 1x. And this problem is a little bit of a bummer. I know this confused some people, because when you go to subtract 99 from both sides, you get negative x equals negative 5. And that's unfortunate. We don't really want negative x. So let's divide both sides by negative 1. And that's going to leave me with the fact that x must be 5. And so we look over here and, oh, I guess I'm not done because it didn't actually ask me for what x was. It asked me for what is the angle ABD. And ABD is 84 minus 2 of these x's. Well, if x is 5, then 2 5s is 10. So 84 minus 10 would be 74 degrees. And we're done with that one. Now, on number 4, I basically gave you a protractor, right? And I noticed that this is pointing at the angle 50 degrees. And if I follow on the outside, this one is pointing to 50 degrees. Way over here, this one is pointing to 140 degrees, or at least it's supposed to be. It's technically, I think, a little bit under, but it's close enough. So if I wanted to know what is the measure of that angle in between them, how far is it from 50 to 140? Well, all I need to do is subtract. And I found out that that angle in the middle, that value in there would be 90 degrees, okay? Now, the part that is a little trickier is if I said, let's go ahead and bisect that. Well, I should know that the middle of 90 degrees would be 45 degrees. So I want to come this way 45 degrees and this way 45 degrees. So either I could take it away from 140 to come to the left, or I could add it to 50 and go to the right. But either way I do, I'm going to land at 95 degrees, which is about right there. And so now I can take out a straight edge and I could make an angle that goes right through 95 degrees. And that should mean that this angle right here and this angle right here are in fact the same. I've made an angle bisector. Okay, number 5 should be a quick question. It's just some vocabulary. We should know that angle 1 is most definitely an angle that is below 90 degrees, as is angle 3. So it says, let's name all of them. And I believe those are the only 2 angles that I have because the top and the bottom are definitely obtuse. If I tried to look at this larger angle, that would be a straight angle. That's not going to work either. Literally 1 and 3 are the only acute angles that I have, but it also says to name them in as many ways as I can. So instead of calling it angle 1, I could also call it angle AED. Now remember, you need 3 letters where the vertex is in the middle. And I could also then, instead of calling this angle 3, I could call it angle BEC. So that would kind of establish that question. And I mean, I guess somebody else could say, well, couldn't we call it CEB? And I guess that would be a potential as well. Or over here, we could call it DEA. That would actually technically be a different name of that angle, so we could include that as well. Now, on number 6, this was, some people had some ideas, but probably the easiest break of this problem is to break it into a simple trapezoid on top and a triangle on the bottom. So what we want to remember is that a trapezoid is you add the 2 bases, divide by 2, and then multiply by the heights. The triangle at the bottom is base times height divided by 2. So we're going to look at both of those stories and try to come up with those areas. So what I see is that the base of the trapezoid is 10 and 19. So I got 10 plus 19 divided by 2. And what I can see is since this entire value is 13 and this part is 7, then that means this little part over here is 6. And that would be specifically the height of the trapezoid. So if I put that together, I could say then, you know, there's a few ways we could do this. In fact, I like a different way better, but I think many of you would do this. 10 plus 19 divided by 2, I got 14 and a half, but now I multiply by 6, and we're looking at 87 would be the area of the top portion of this shape. Now, the bottom one, this triangle has a base of 19, and it has a height of 7. And so 19 times 7 divided by 2 is a nice, easy number of 66 and a half. And so if I wanted to find the area, I would want to add those 2 numbers together. And I got 153 and a half. Now, for this particular story, let's suppose that this was the shape of somebody's backyard, and I wanted to put some pretty, you know, like lawn in there, but I didn't want to wait for seeds to come up, and it cost me $27.75 per square yard. Well, this is the number of square yards. So if I took 153.5 square yards and I multiply it by $27.75 per square yard, all I need to do is take this 153.5 and multiply it by 27.75, and I found out that the cost of putting a lawn in this area is $4,259.63. I rounded up to the nearest penny. And that will be the end of our little demonstration video on the review for Module 1. All right, I will see you guys back in class. Bye-bye.